Download this code from codegive.com, link in the description below. OK, let's dive deep into the world of block diagram reduction, starting with part 1. This will be a comprehensive tutorial, covering the basic rules, explanations, examples, and code snippets, primarily using Python with libraries like Control for system representation and matplotlib for visualization where applicable. Part 1, Introduction and Basic Reduction Rules. 1. What are block diagrams? Block diagrams are a graphical representation of a control system, or any dynamic system. They use blocks to represent individual components, transfer functions, summing junctions to indicate addition or subtraction of signals, and takeoff points to duplicate signals. They provide a visual and intuitive way to understand the flow of signals and the relationships between components within a system. Why use block diagrams? Visualization makes complex systems easier to understand at a glance. Analysis simplifies the mathematical analysis of systems. Design aids in the design and modification of control systems. Communication provides a standardized language for engineers to communicate about system architecture. 2. Key elements of a block diagram. Block represents a transfer function, G, S, or a specific operation performed on the signal. The input signal is multiplied by the transfer function to produce the output signal. Output, S, equals G, S, input, S. Summing junction, summer represents the addition or subtraction of two or more signals. Signals entering the summer are added, if marked with plus, or subtracted, if marked with dash. Takeoff point, branch point represents a point where a signal is duplicated and sent to multiple locations. The signal at a takeoff point is unchanged, it's simply branched. Arrows indicate the direction of signal flow. Reference input, R, S, the desired input to the system. Output, C, S, the actual output of the system. Error signal, E, S, the difference between the reference input and the feedback signal, usually. Feedback signal, B, S, the signal fed back from the output to the summing junction. Forward path the path from the reference input to the output. Feedback path the path from the output back to the summing junction. 3. The goal of block diagram reduction The main objective is to simplify a complex block diagram into a single equivalent transfer function that relates the output C, S, to the input R, S. This equivalent transfer function is often denoted as T, S, equals C, S, / R, S. Finding T, S, allows us to analyze the system's overall behavior, stability, response characteristics, etc. 4. Basic block diagram reduction rules, Part 1. Here are the fundamental rules that we will cover in this part of the tutorial. Combining blocks in cascade, series. If two or more blocks are connected in cascade, series, their transfer functions are multiplied together to form a single equivalent block. If you have blocks G1, S, G2, S, Gn, S, in series, the equivalent transfer function is Gk, S, equals G1, S, G2, S, Gn, S. Combining blocks in parallel. If two or more blocks are connected in parallel, their transfer functions are added together, taking into account the signs at the summing junction, to form a single equivalent block. Asterisk if you have blocks G1, S, G2, S, Gn, S, in parallel with appropriate signs, plus slash at the summer, the equivalent transfer function is gc, S, equals G1, S, plus or minus G2, S, plus or minus Gn, S. Asterisk moving a takeoff point behind a block asterisk to move a takeoff point from before a block G, S, to after the block, you need to introduce a block with a transfer function of 1 slash G, S, in the branch originating from the new takeoff point. Asterisk original configuration asterisk. Input dash takeoff dash G, S, dash output, dash branch. Asterisk equivalent configuration asterisk. Input dash G, S, dash takeoff dash output, dash, 1 slash G, S, dash branch. Asterisk moving a summing point behind a block asterisk to move a summing point from before a block G, S, to after the block, you need to introduce a block with a transfer function of G, S, in the branch entering the summing point. Asterisk original configuration asterisk. Input 1 dash, plus, dash G, S, dash output. Input 2 dash, plus, dash. Asterisk equivalent configuration asterisk. Input 1 dash G, S, dash, plus, dash output. Input 2 dash G, S, dash, plus, dash. 5. Examples and code implementation, Python. Let's illustrate these rules with examples and Python code using the control library. Example 1, Cascade blocks. Suppose you have two blocks in series. Asterisk G1, S, equals 1 slash, S plus 1. Asterisk G2, S, equals 2 slash, S plus 2. Explanation asterisk. Asterisk we use control.tf, to define transfer functions using numerator and denominator coefficients. Asterisk control.series, or simple multiplication G1 asterisk G2, computes the equivalent transfer function of the cascade connection. Asterisk the output shows the equivalent transfer function, which is 2 slash, S caret 2 plus 3's plus 2. Example 2, parallel blocks. Suppose you have two blocks in parallel. Asterisk G1, S, equals 1 slash, S plus 1. Asterisk G2, S, equals 2 slash, S plus 2. Asterisk the summer configuration is R, S, plus G1, S, G2, S. Explanation asterisk. Asterisk control.parallel, G1, G2, adds the transfer functions in parallel, in this case, G1, G2. Pay close attention to the sign of G2 corresponding to the summer configuration. Asterisk the output shows the equivalent transfer function after the parallel combination. Example 3, moving a takeoff point behind a block. Let's say you have a system with a takeoff point before the block G, S, equals 1 slash, S plus 1, and you want to move it behind the block. Explanation asterisk. When moving the takeoff point behind the block G, S, you would add the 1 slash G, S, to the takeoff signal branch. Since we cannot graphically represent in this text-based format the block diagram and the signal flow, this code example only shows the computation of the 1 slash G, S, transfer function. Example 4, moving a summing point behind a block. Explanation asterisk. When moving the summing point behind the block G, S, you would multiply the second input signal by the transfer function G, S. Since we cannot graphically represent in this text-based format the block diagram and the signal flow, This code example only shows the computation of g, s, for the second input. 6. Important considerations asterisk asterisk. Asterisk signs asterisk be extremely careful with the signs at summing junctions. Incorrect signs will lead to incorrect results. Asterisk order of operations asterisk there's often more than one way to reduce a block diagram. Choose the most efficient sequence of steps. Asterisk algebraic manipulation asterisk remember that transfer functions are algebraic expressions. You can use algebraic manipulation to simplify them. Asterisk iteration asterisk block diagram reduction is often an iterative process. You may need to apply the rules multiple times to arrive at the final equivalent transfer function. Asterisk no general Python implementation asterisk the control library does not offer built-in functions to move summing points or branch points. These operations require more complex algorithms that aren't common in regular control analysis. Therefore you have to manually manipulate the block diagram mathematically, and re-implement it as a code, as needed. 7. Summary of Part 1 asterisk asterisk. In this tutorial, we covered asterisk the basic definition and purpose of block diagrams. Asterisk the key elements of block diagrams, blocks, summing junctions, takeoff points. Asterisk the goal of block diagram reduction. Asterisk 4 fundamental reduction rules. Asterisk combining cascade blocks. Asterisk combining parallel blocks. Asterisk moving a takeoff point behind a block. Asterisk moving a summing point behind a block. Asterisk examples of these rules with Python code snippets. This foundation is crucial for tackling more complex block diagram reduction problems. Part 2 will build upon these concepts and introduce more advanced techniques, including the reduction of feedback loops and more complex scenarios. Remember to practice these rules to gain a solid understanding before moving on.